Alright, good morning. I'm going to go over Friday's homework for anybody that was taking the AP test on Friday, and then go over just 2 problems yesterday and what we're learning today. So, first of all, here are your answers for Friday's homework. How many cards are in a standard deck? It is 52. You are going to need to know that for the quiz. There are 4 different suits. There are hearts, diamonds, clubs, sorry my ugly handwriting, and there are spades. How many cards are in one suit? There are 13. And the probability of drawing a black or a red card is a 100%, or you could write 1. No matter what, you're going to draw black or red. What's the probability of drawing a heart? You have a 1 in 4 chance because there are technically 13 out of 52, and that reduces. What is the probability of drawing a card less than 7? It says ace is high, so it's going to be 2, 3, 4, 5, or 6, because 7 is not less than 7. So that's 5 different numbers. There are 4 different suits, so that's 20 out of 52, which ends up reducing to 5 out of 13 if you divide them both by 4. What's the probability of drawing a 4 or a 3? That's 2 different cards, 4 and 3, and there are 4 suits, so that's 8 out of 52, which ends up reducing to 2 out of 13. And what's the probability of drawing a card greater than 13? 0, because no card is greater than 13. Now we have a box that contains all these different balls. So total we have 2, 4, 1, 3, and 1. That's 11 total. What's the probability of drawing a blue or orange? Well, blue and orange total is 4 out of 11. What's the probability of drawing a white ball? That's a 1 out of 11. Not replacing it, and then drawing another white ball. Well, if I've already drawn one, there's 0 chance of drawing another. So then 0 times 1 is 0 out of 110, which is 0. What's the probability of drawing a ball that is not red? So there are 2 red balls, so that's not red is 9 out of 11. Putting it back, so we're still going to have 11, and then drawing a red ball, which would be 2. Well, that gives me 18 over 121. I can't reduce that, so my answer is 18 over 121. Probability of drawing a white ball, 1 out of 11. Sorry for all the email noise. And then a green ball, and you're not replacing it. So if I'm not replacing it, I only have 10 left, and there are 4 green balls. So that gives me 4 out of 110, which reduces to 2 out of 55. Turn it over. We have the letter word banana is on a card. Find the probability of you picking 2 cards without replacing. And banana, that means we're going to have 6 cards total. So this P means the probability of. So picking a B, that's going to be 1 out of 6. And then an N. Now remember, we're not replacing it, so there are only 5 cards left. We're assuming we picked a B that first time, so then there are going to be 2 N's. So when I multiply, I get 2 over 30, which equals 1/15. Right here, an A, there are 3 out of 6, so that's 1/2 A's. And then an N, remember, we didn't replace it, so it should be a 5. And how many N's are there? 2. So 1 times 2 is 2 over 10, which gives me 1/5. An A, So we already said there are 3 out of 6 A's, so that's 1/2. Now I'm not going to do 1/2 again because we're assuming we picked that A. So now there's 2 A's left out of 5 cards. So that gives me 2 out of 10 as well, which is 1/5. An A or an N. Well, 5 out of 6 are an A or an N. And then we only have 5 cards left, and we took an A or an N, so only 4 out of 6 are an A and N again. So that gives me 20 over 30, which reduces to 2/3. What is the probability of guessing the correct answer to a multiple choice question if there are 5 answer choices? You have a 1 out of 5 chance, which is 20%. Probability of guessing a true-false question, you have a 1 out of 2 chance, which is 50%. What's the probability that your birthday will fall on a Saturday or Sunday? Now, I know your birthday is 1 day out of 365 days a year, but since we're talking about Saturdays and Sundays, your birthday can only fall on Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, or Friday. So you have 7 options, and Saturday or Sunday gives you 2 out of 7. Oops, sorry. Okay, so what is the probability of winning a raffle ticket if 500 tickets are sold and you buy 5 of them? That would be 5 out of 500, which reduces to 1 out of 100, or 1%. In the alphabet, what is the probability of randomly choosing a letter in the word mathematics? Some of the letters repeat, so it's really 8 out of 26 letters, but we can reduce to 4 out of 13. And I'm just going to give you these answers to these. Once you reduce them, you get 4 over 11, or 36.4%. 1 over 13, or 7.7%. It says round to the 10th. And then 3 over 7, or 42.9%. And then this is kind of what we did today, or yesterday for most of y'all, is if you have a team and they're landing in a circle on the football field, your circle is where you would want them to land. That's like the shaded region. So I got to find the area of the shaded. It says the diameter is 20. So if the diameter is 20, what's my radius? Oh, that pen doesn't work. My radius is 10. You done? All right, thank you, ma'am. So what would be the area of this circle if my radius is 10? It would be 100 pi divided by the area of the whole thing, which would be 160 and 360, which gives something like, I don't know, my calculator's out. I think it's 5,700? Nope, 57,600. So then when I divide those, I'm going to do alpha y equals 100 pi divided by, and then I need to times by 100, which gives me 0.5%, which is the B. All right, so now we're going to go on to what we are learning today. And sorry, you should have picked up, bye ladies, this paper when you walked in. Write your name on it. So how many possible outcomes are there when you flip 2 coins? Well, the first coin, you can get a heads or a tails. And then after you flip that first coin, you can either get a heads and a heads or a heads and a tails, or you can get a tails and a head or a tails and a tails. So how many are there? There are 4. What about when you roll a number cube and then flip a coin? Or I can roll a 1, a 2, a 3, a 4, a 5, or a 6. Any of those. And then I could either flip a heads or a tails. A heads or a tails. a heads or a tails. So I could either have you draw out this diagram every time. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or what could you do? The first option, flipping a first coin, you have 2 options. The second one, flipping a coin, you have 2. That gives me 4. Rolling a number cube, how many options are there? And then flipping a coin. So what is that? That's 12. This is called the fundamental counting principle. So it's multiplying the number of choices for each option. So if I asked you, how many choices could we make given a lunch special if you had to purchase an entree, a side dish, and a drink? How many entrees are there? 3. Side dishes? 3. How many different drinks? 4. 3 times 3 times 4. So there are 36 different combinations that you could make. So now I'm going to do, oh, nope, we got one more example. In Utah, a license plate consists of 3 digits followed by 3 letters. The letter I, O, and Q are not allowed to be used because they look like 1, 0, and 0. Each digit or letter may be used more than once. How many different license plates are possible? So 3 digits and 3 letters. 3 digits, 3 letters. How many different digits are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 different digits because 0 is included. I just counted 10, sorry. And it says each letter may be used more than once, so each digit there's 10 options. Now for letters. There are 26 letters in the alphabet, but we cannot use these 3. So minus 3, how many options do they have? 23 options. So when I put that in the calculator, well, that's going to be a big number. I'm multiplying all these numbers. And so they have 12,167,000 different license plate options with this criteria. So now I'd like you to pause the video, please, and answer practice number 1 through 3. Alright, I'm about to show the answers for the first 3, and here they are. Oh, let me box my answers. Okay. The next thing we're going to learn is factorial. And actually, this question was on your, oops, I'm showing you something early. This was on your TEKS test. How many ways are there to order 7 different colored cups? 1, 2, 3, 4, 5, 6, 7. Well, if you have 7 different colors in that first spot, you have 7 options. Once you place it there, then you have 6 options. Then 5, 4, 3, 2, 1, which gives you 5,040 different ways to arrange your colored cups. Now this is called factorial anytime you're multiplying to go down. So the way that you would put this in the calculator, another way you could do it, hit math, arrow over, we're in probability, and there's your exclamation point. So you could hit 7 and then math, and it gives you the same thing. So the key thing when you see this, anytime we're doing factorial, is when you're arranging something. Okay, so factorial, the definition is the product of a list of descending, oops, I spelled that wrong, numbers to 1. So I want you to practice 4 through 8. Again, pause the video for about 2 minutes, and I'll give you the answers in a second. Alright, and I'm about to show you your answers. There you go. So again, a key word is arranging, or I guess how many orders are possible is a big thing too. So, what if we wanted to pick different arrangements from a set of numbers? So for example, what if I wanted to select an order of 3 people out of a group of 7? So let's say I want to choose number 1, number 2, number 3. But I have 7 different people. Well, now I would only have 3 blanks, but how many people can I choose from in the first? 7. What about my second person? There's 6 people I can choose from. For my third person, 5. I don't really care about the others, so I'm going to stop here, and I get 210. This is called a permutation. So I want you to write this right here and right here for permutation. So a permutation is a selection of a group of objects which order matters. I want you to underline order matters, or order is important. Underline, highlight, do something special. And then please write out this formula right here. Now, N is going to be your number of total items, and R is going to be your number of selected items. So I'm going to explain what that means in a second. I'll give you time to write this down. So really for permutation, I rarely use the formula. Because we're selecting a certain number of people, what I usually do, because order matters, right here, this tells me I have 7 people total, but I only want to choose 3. So 1, 2, 3. How many people do I have to choose from? 7, 6, and then 5. And then I can just do that in the calculator, and I get 210. Now, could you technically do the formula? Absolutely. It would be your 7 factorial over, what's 7 minus 3? 4 factorial. And you could do this in the calculator by doing alpha y equals 7 math arrow over, oh, oops, I didn't finish it. I pushed enter too quick. Okay, and then we got 4 math arrow over, we got factorial. And it gives us the same thing. So I'm going to show you both ways. Right here, I have 6 people to choose from, but I only want 2 spots. My first spot, how many people are there? My second spot. So what's 6 times 5? Again, in my opinion, that is way easier than doing 6 factorial over 4 factorial, because 6 minus 2 is 4. So if I do that, oops, this to me is just a little bit more time consuming, because you have to go, there's no easier way to do the exclamation point. And then last but not least, there are 10 people to choose from, but I only want 3 spots. So 10 times 9 times 8. gives me 720. Or you could do 10 factorial over 7 factorial because 10 minus 3 is 7. It will give you the same answer. All right, I'm going to give you a minute to do number 12 and 13. Go. All right, and your answers are there. Okay, so permutations, again, order matters. A lot of times you're going to be using permutations when first, second, or third place. A president and a vice president. You have first chair and second chair in band or orchestra. It's when you care about who comes first and who comes second or third or fourth. The other way we might have it is with combinations. Now, a combination, you're writing this in that next blank. So turn your paper over, we're writing that as our definition right up here. It is a group of objects in which order does not matter. Okay? So in this explanation, I want to know the different ways you can arrange the letters A, B, C. Permutation, you can have A, B, C, A, C, B. You see how the order matters here? It depends where A and B, C go. A, B, and C go. A combination is just basically saying, hey, I have 3 letters. It doesn't matter what order. So order does not matter. Here is your formula for combination. So this one has that extra R out front. This one's the one that's a little bit harder to remember. And for this one, we're going to have to do the formula because I don't know another way to do it. So we're going to write NC of R equals N factorial. Okay. So over here, I'm going to do these examples with you. I have 11 options, but I want 3 letters. So again, order doesn't matter. So I'm going to do my 11 factorial over 3 factorial. And then I'm going to subtract them. 11 minus 3 is 8 factorial. So alpha y equals, I'm going to do 11 factorial over 3 factorial and 8 factorial. So I get 165 as my answer. For this one, I have 11 factorial over 5 factorial, and then I need to subtract them. 11 minus 5 is 6 factorial. So I'm going to go up and just change this so I don't have to waste so much time. Y'all see what I just did? And that gives me 462 combinations. All right, I'm going to give you a little bit of, here's an example, a word problem. The swim team has 8 swimmers. 2 swimmers will be selected in the first heat. How many ways can the swimmers be selected? So you would say 8 combination. There's no order what those 2 swimmers are. So 8 factorial over 2 factorial, and then subtract them. So let's plug that in. I arrowed up. 8 over 2 and 6. So there are 28 different ways. Now let's say I said the swim team has 8 swimmers and I want to know the different permutations of first and second place. Well, there first and second place matter. So there are 8 possible people that could win first and 7 that could win second. There are 56 permutations. So you see the difference of combinations and permutations. Okay? You are now going to practice 16 through 18. Pause the video and then I'll give you the answers. Alright, about to reveal the answers. And there you go. So I'm going to give you, again, pause the video. You are going to identify which one of these at the bottom, if they're counting principle, factorial, permutation, combination, or just plain old probability like I did at the beginning of the video. And then okay. So I'm going to give you, pause the video for about, let's say 3 minutes and see if you can get these, and then I'll give you the answers. All right. So here are your answers. Anytime you see arranging, that's going to be your factorial. Combinations, anytime I'm doing outfits or foods, well, not always foods because not right here. License plates, things like that, that's always going to be your counting principle, the first one we learned. Number 21 and 30, order matters because it's first, second, and third, president and vice president. Number 28, 26, 25, order does not matter. Sorry, that's a D. I thought combination, so I put C, and then I realized it was the wrong letter. You now have a mixed practice that you are going to spend the rest of the class period doing. Tomorrow when you get into the class, we'll go over this, and then we're doing our breakout box. Good luck. Thank you.